Hello, my dear students. Today, in this lecture, let us solve some of the numerical on condensation. See, in this problem, it says a vertical cooling film, approximately a flat plate 40 centimeter in height. So the height of the plate is 40 centimeter, that is nothing but the length as 0.4 meter. Is exposed to the steam at atmospheric pressure. So steam is at atmospheric pressure. Atmospheric pressure means we take the saturated temperature as 100 degrees centigrade. If the surface of the fin is heated at 80 degrees centigrade, that means the fin surface temperature is 80 degrees centigrade, make calculations for the film thickness at the bottom edge of the fin. That means at L is equal to 0.4, you need to find out the delta value, delta L. Then overall heat transfer coefficient, HTC, and heat transfer rate and condensate mass flow rate. That means heat transfer rate, you need to find out the value of Q, and condensate mass flow rate, M dot. First thing is, here he has given at atmospheric pressure steam is getting condensed. So at T saturated temperature, we need, what is the T saturated temperature? At atmospheric pressure, it is 100 degrees centigrade. So at 100 degrees centigrade, we need to note down the HFG value. It is 2257 into 10 power of 3 joules per kg. Then all the properties of the water or the liquid we need to take at the mean film temperature. That is 100 degrees is the vapor temperature plus surface temperature is 80 divided by 2. We'll get the average as 90 degrees centigrade. Now go to the data handbook, take the property values of the liquids at saturated state, and we have already seen many times. Go to the water condition and that table, we have seen this table, right? So at this condition at 90 degrees centigrade, so obtain the values of rho L, that is density of the liquid, mu L, it is the kinematic viscosity. So from mu, we need mu, that is dynamic viscosity, multiply these to obtain the dynamic viscosity, and the K value, that conductivity value. So all these values we need to take from the liquid property table, that wherein we use water here at the average temperature of the surface and the vapor temperature. Then we need to find out the film thickness at the bottom edge of the fin. For this, we need to go to the condensation table. Let's go to the condensation table in the data handbook. Now, you can see here the data handbook, you go to this table, film condensation, and under that you go to this vertical surface. So in the vertical surface, they have given delta X is equal to 4 mu L K into X into TV minus TS divided by G HFG rho square whole power 0.25. So mu L is the dynamic viscosity of the liquid. Just now we obtained for water. Then K is the thermal conductivity of the liquid. Again we obtain X is the distance. For this condition they have asked at the end of the plate. So we have to take the length of the plate L as the X condition here. Then TV is the vapor temperature minus surface temperature Ts. So it is 100 minus 80 divided by G is the 9.8. HFG is the latent heat and it is at vapor, that is 100 degrees centigrade, and rho is again the density of the fluid which we obtained at 90 degrees centigrade for this problem. Then this is delta L, that means the thickness of the boundary layer at the length L. Then go here HL, find out the HL value. HL is the local heat transfer coefficient. It is K by delta L. Once you get the local heat transfer coefficient, to obtain the average heat transfer coefficient, you can use this H is equal to 4 by 3 L. If not, if you want the average heat transfer coefficient directly, you can also use this expression for the average heat transfer coefficient. So all these conditions are for this particular problem, vertical surface. The next problem, when we go for horizontal tube, you need to use this equation, and if you go for bank of tubes, you need to go for this expression. Now, let us go back to the problem. Here now we need to find out the film thickness at the bottom of the fin. So delta x is equal to is the formula. At the bottom of the fin is x, we have to put the length L. L is 40 centimeter, that is 0.4 meter. Substitute all the values. 4 mu L is the dynamic viscosity for the liquid, K is again for the liquid the conductivity, X is the length here, TV minus TS divided by G, HFG value and rho value again for the liquid. Then you calculate, you'll get the thickness of the boundary layer at the end of the plate. Next, to find the overall heat transfer coefficient, I am using directly the formula which I showed you just now in the data handbook. So go back, go to this formula, substitute for K, rho, G, HFG value, mu L and L value and the difference in temperature delta T. Then you will get the average heat transfer coefficient. Then to find the rate of heat transfer, we have it, we know Q is equal to HA delta T, H into A. What is A? A is nothing but length into breadth, right? Because since it is a vertical plate. So length we know 0.4 meter, breadth is not given, we assume it as 1 meter, multiply by this delta T. So this is the, sorry, actually it is desaturated 100 minus it is 80 surface temperature. So you'll get the value of Q here. Next, once you get the value of Q, Q is equal to m dot into HFG, we know. So what is m dot? Mass flow rate of the condensate will be equal to Q divided by HFG. So Q value you obtain divided by HFG, you will get the mass flow rate of the condensate. Then we'll go to the next problem. Next problem says the dry saturated steam at a pressure of 2 bar condenses on the surface of the vertical tube of height 1 meter. So previous case it was at atmospheric temperature, but here in this case it is saying the pressure of 2 bar. Okay, so and the tube surface temperature is kept at 117 degrees centigrade. Surface is 117. Estimate the thickness of the condensate film and the heat transfer coefficient at a distance of 0.2 meter from the surface. That means it is not the length at the end of the plate. It is at a distance of 0.2 meter from the leading edge of the plate or the upper end of the plate. So delta x is equal to 0.2. Assume condensate film to be laminar. Calculate the average heat transfer coefficient and the rate of heat transfer over the entire length of the tube if the tube is of the diameter of 0.1 meter. So diameter of the tube we have given, then you need to find the entire length. Over the entire length, we have to find out the average heat transfer coefficient. So from this, you are here, please note sure, since the data handbook contains only for at atmospheric pressure, you need to go to the steam tables. Go to the steam tables and at pressure of 2 bar, get these values. Desaturated value at a pressure of 2 bar and it is obtained as 120.23 degrees centigrade. Then this is the specific volume we have. We cannot get the density value directly there. We need to obtain the specific volume there and take the reciprocal of this specific volume to get the density of the gas or the vapor. So this is a G is nothing but gas or V vapor, both are the same here. Then HFG value, latent heat value at 2 bar pressure you need to find out, since the condensation is occurring at 2 bar. So get the value of HFG value. Then go back to the data handbook value, and in the data handbook value, get the properties of the liquid in saturated state at the average temperature, that is desaturated plus saturated temperature at 2 bar pressure plus surface temperature 117, you will get the average temperature. So once you get this average temperature, then at average temperature, go to the properties of the water, properties of the liquid table, and there underwater obtain these values, delta, the density value, K value and mu value. Once you obtain all these values, Then to find the thickness at a distance of 0.2 mm, go to the condensation section in the data handbook, take this expression. So substitute the values or the properties which you obtain in this expression for mu L, K, X value is nothing but that distance of 0.2 meters. We need to find the thickness of the boundary layer. So obtain that. Then substitute here divided by G, HFG rho, and we will get the value as delta as 3.78 into 10 power of minus 4 meters. This is the thickness of the boundary layer at a distance of 0.2 meter from the upper end. Then to find the local heat transfer coefficient, at that point it will get it as Hx is equal to K by delta X. So K, then divided by delta X, you will get the Hx value. Then to find the average heat transfer coefficient or the entire length L, so go to that complete expression. Then substitute the average heat transfer coefficient. Don't go here because this is, you will get it only at that location point 2. But if we want for the entire length L, you go to this expression directly, the average heat transfer coefficient expression. Then here you substitute this K value, rho value, G value, HFG value, delta T value, mu value, and L is the length of the complete plate is 1 meter value. Then you will get the average heat transfer coefficient. Then to find the rate of heat transfer coefficient, we know Q is equal to HA delta T, we know H into A. A, since it is a tube, it is a vertical tube, you need to find, you have to put the area as pi into D into L. So pi DL multiplied by TV minus surface temperature minus the, this is again the saturation temperature minus surface temperature delta T, you will get the value of Q. Then go to the next problem. Here this is outer surface of the cylindrical drum is 350 mm. So D is equal to 0.35 meters. There is diameter exposed to saturation steam temperature at 2 bar. So steam is at 2 bar temperature. Saturation temperature is 2 bar for condensation. So if the surface temperature of the drum is maintained at 80 degrees centigrade, surface temperature is 80. Calculate the length of the drum. Also calculate the thickness of the condensate. So find the mass flow rate. From steam tables at 2 bar pressure, get the saturated temperature. So it is 120.23. So HFG value is 2201.6 into 10 power of minus 3. This is at 2 bar pressure. So this is at the vapor value, properties. Then for liquid properties, take the average value. So you'll get here again average as 100 degrees centigrade. Go to the water table, average value, and at 100 degrees centigrade obtain the density, mu L and K values. Then go to the section wherein you have to find the length of the drum. If you use delta is equal to at X is equal to L, get substitute here and it will be in terms of L because we do not know the length of the drum. So just keep L as it is and continue, and HL will be equal to K by delta L. Again K by delta L, you all consider or take the expression in terms of L only, where HL is the local heat transfer coefficient at 10th L. So to get the average heat transfer coefficient, go to 4 by 3 HL. So 4 by 3 into HL. So what will be H? We will get, this is the H bar, the average heat transfer coefficient. But rate of heat transfer is Q1 by Q is equal to H bar into A into TV minus TL. That is nothing but mass flow rate into HFG. So substitute this expression. Area is pi d L. L we do not know. Again keep it as L as it is. Then again the difference in the temperature, that will be equal to vapor temperature minus the surface temperature. So substitute, that will be equal to m dot into HFG. So once you substitute in this equation, obtain the, where here only L is the unknown factor, for L obtain the value, and L value is obtained as 0.1266 mm. So that is 126.6 mm as the length of the plate. Next, we'll go to the next problem. It says a tube of 13 in diameter, outer diameter, and 1.5 meter long is used to condense steam at 40 kilopascal. So diameter is given, length of the tube is given, and calculate the heat transfer coefficient for the tube in horizontal and vertical condition. So you have to use two expressions. One is for H for the horizontal, H for the vertical. Take the average tube wall temperature at 52 degrees centigrade. So wall temperature is 52 degrees centigrade. But the steam tables, you have to go, it is saying the steam is condensing at 40 kilopascal. So at 40 kilopascal, that is nothing but 0.4 bar. At 0.4 bar from the steam table, get the TB vapor temperature or the T saturated temperature as 76 degrees. It's also given the problem, and obtain the HFG value from the table, steam table HFG value. Then go to the data handbook, get the properties values at the average temperature. At the average temperature, obtain the property values of delta L, the density value, conductivity value, and the viscosity value. Then in first case, we need to find the heat transfer coefficient in the vertical position. So in the vertical position, same expression, get the average heat transfer coefficient, substitute for all the values, we'll get the average heat transfer coefficient. To find the heat transfer coefficient in horizontal position, go to the next expression where it says for the horizontal position, obtain here, but only difference between these two we obtain is in the vertical position you will put L here, in the horizontal position we substitute the diameter here and get the H value, that average heat transfer coefficient in the horizontal position. Next, we'll go to the last problem, which says the air free saturated temperature is at 85 degrees centigrade and pressure is 57.8 kilopascal. So, saturation pressure is 57.8 kilopascal. So, I convert it to bar 0.058 bar. So, obtain the saturated value or the vapor temperature and HFG temperature. HFG at this temperature, that is latent heat. Then here this air condenses on the outer surface of 225 horizontal tubes of 1.27 centimeter. So horizontal tubes of diameter 1.27 centimeter. It is arranged in 15 by 15 array. So tube surfaces are arranged. That means you have a vertical tube. You have 15 by 15, 15 tubes horizontally and 15 tubes vertically. Totally 15 by 15. It is 225 tubes you have. The tube surfaces are maintained at an uniform temperature of 75 degrees centigrade. So surface temperature TS is at 75 degrees centigrade. You need to find out the total condensate per meter length of the tube bundle. So number of tubes. If the number of tubes are directly given as then you have to take the square root of that to get the value of n. Or if n is directly given, you can take the number of rows and number of columns, and number of rows is given as 15 rows with 15 columns. So to find the horizontal heat transfer coefficient, go to that expression of the heat transfer for bank of tubes. So H average will get this expression where you will have extra term n value here. N is nothing but the number of horizontal rows. Then D is the diameter of the tube. Then substitute for K, rho, G, HFG and all these which we obtained from the data handbook. Then, so how do you obtain? Then for again to get the properties, you have to go to the TF, that is mean temperature, get the mean temperature as 80 degrees centigrade and at 80 degrees centigrade, obtain these values or the properties. Then after getting these properties, go to the H average expression, substitute with n as 15 and here this is the diameter of the tube and all other properties are if it is given here, get the value of H. Once you get the average value of the H, so we know rate of heat condensation Q is equal to H into surface area into the saturation temperature or the vapor temperature minus surface temperature. That will be equal to m dot into hfg. Substitute here. So what is m dot is equal to h into as into tv minus ts divided hfg. As, what is the surface area? Surface area of the single tube is pi into d into l, multiply by number of tubes, because we have total number of tubes as 225. Don't take it as 15, which is the number of rows, but here you need to take total number of tubes as to 15 by 15, that is 225 tubes, divided by hfg. So then substitute all these values, h value, pi, d diameter of the value, l per meter length is given l as 1, then tv minus ts, multiply by total tubes 225 divided by hfg. You will get the mass flow rate. Okay, thank you.